All right, we're looking at Circle Quiz 4 from last Friday. Equation of circles and a formula which allows us to find the length of arcs, arc length. That was the two big topics on this quiz. Um, as we look at how things went, kind of in between, I guess, a couple weeks ago, we had a really high average, and then last week it was fairly low. Um, this week, kind of in the middle. 16 out of not 23, but 20 would be like right at an 80%. And notice the mean and the median were um, were exactly the same. Also notice the range, pretty big range all the way from perfect down to 8. Um, Whenever you have an average and whenever you have a mean and a median that are the same, you kind of look at the shape. And as you can see here, this is a pretty good normal distribution right there. We studied those a couple weeks ago, data analysis stuff. And anytime that the, the mean and the median are pretty close to the same, you oftentimes will get this fairly normal looking curve that most of the scores are clustered in the middle, with fewer and fewer the further out you go. So you guys definitely achieved that. And of course, if you, just in case you don't believe me, there you go. Look at that. Pretty much right in that shape. Anyway, moving on. These were the two big questions outside of the bonus 7 and 8, which we had issues with. Only 10 out of 23 people got number 7 correct. Number 8, only 8 out of 23. So we'll definitely take a look at those two. Problem number 1 here was just applying the equation of a circle, right? This guy right here. We just need to know what h is, we need to know what k is, and we need to go and plug them in, figure out what the radius is. It looks like h was -5, k was 2, and r was, the radius was 3. Um, Sometimes people forget to square the radius, and sometimes people get the minuses here confused and think that the negative in the formula, the minus sign, subtraction sign, stands for the negative up here, which is definitely not the case. So if you have a negative h or k value, that's going to create a double negative. If you have a positive h or k value, it stays positive, it just stays as y minus. And don't forget to square the radius. Those are some pretty common mistakes, forgetting the negatives, or getting the negatives mixed up and forgetting to square the radius. Now, with that being said, notice that every single person got this one right. I want you to keep that in mind, because unfortunately that consistency does not stay with us. There are problems later on where if people did the same thing on problem 1 as on later problem, they would have gotten those problems right also, but they didn't. So we'll keep an eye out for that. Once again, equation of a circle. This time we have an equation that's in what we call general form, general conic form, and we need to turn it into standard form, which is your x minus h y minus k equals r squared form. But how do we do that? Well, we use a trick called completing the square, right? So I'm going to take the x terms, which are here, and let's use different color, which are here and here. I'm going to group those. And I'll take the y terms here and here, and I'm going to group those. And I'll take that 20 and just clear it out, move it entirely to the other side. So negative 20 becomes positive 20 on the other side. Half of 8 is 4 squared is 16. Don't forget to add the 16 to the other side. Half of 6 squared is half of 16 is 8 squared is 64. Add that 64 to the other side. So we're going to end up with 100 on the other side. We now can square our perfect binomials that we made. So this becomes x minus 4 squared y plus 8 squared. And boy, that looks an awful lot like letter D. Okay, so number 2 was D. By the way, I don't know if we gave the answer on number 1, but it sure looks like it was B. Okay. Yes, so almost everybody got number 2 correct. Okay, what mistakes were made? Both C. Which, yeah, it looks like probably it was forgetting to add something to the other side, or maybe just moving the 20 to the other side and keeping it negative. That could have affected it too. But whatever happened, we didn't end up adding these values to get 100. And that's where we were off. But still, 91% is pretty darn good. I would give you a thumbs up on that too. Number 3. Okay, so now we're doing a circumference area problem. This, by the way, is a classic circumference area problem. I've never proctored, and I probably proctored, I don't know, 30 or 40 ACTs over the years on Saturday mornings, and I always kind of flip through, take a look. I've seen this as one of their 60 math questions every single time. They either give the circumference and ask for the area, or give the area and ask for the circumference. So these two formulas, circumference and area, are must-knows. Got to know those. They gave us the circumference in this case, so we're gonna, cancel those pi's and probably divide by 2. That gives us the radius. Once I know the radius, I can plug that in and square it, and 169 pi. And if there's units, you use units, but here's there are no units, so 169 pi e was the answer. And it looks like we did really well on that. So yes, good job on 3. The people that missed it were either A or B. A is where you forgot to square the radius. You found the radius was 13, but then you just kept it. We didn't square it. And B is we squared it, but we forgot the pi. Okay, it's not right if it doesn't have that pi. It's pi r squared, not just r squared. Number 4, back to circle equations. They gave us the center and a point on the circle, but they certainly did not give us the radius. They want the radius. You could use the distance formula for this, but the equation of a circle basically is the distance formula. It's a little more convenient to use, I think. We know that x. Well, let's start with the center. The center was negative 1 for h and 3 for k. Okay, so we know those two values right off the bat. Furthermore, they gave us a point on the circle. I can use that as an x and a y. So I can put 6 in for x, and I can put negative 5 in for y. So I'm going to end up with 6 minus negative 1, which is 7, or negative 7 if you were, I guess I might have done negative 1 minus 6 to get that one. Negative 5 minus 3 is negative 8, although if I put it in the opposite order, it would have been negative 3 plus or minus 3 minus negative 5, that would have been negative 8, in this case 8. Either way, they're going to square to positive values. They're going to square to positive values. So that's going to give us 113. Now, that's not the answer. If you said A was the answer, you forgot that this was r squared, not r. We do need to take the square root of that. And so C was the answer, square root of 113. Almost all of you guys got that. It looks like D, root 15. Here's what happened on that one. Somebody squared the negative 7 and kept the negative sign and got negative 49. So that when you add netted negative 49 to 64, you got a 15. However, negative times a negative is a positive. The only real number that you can square and not get a positive is 0. 0 squared is 0. Any other real number, whether it's positive, negative, rational, irrational, will always be a positive. Negative times a negative is a positive. Positive times a positive is a positive. So obviously, overall, we did pretty well on that one. Okay. Number 5. So we just need to write the equation of this circle. So we need to figure out what the center is. Well, we see the center. They give us the center. What does it look like? It looks like that is over 3 units horizontally and down 2 units vertically. So H is going to be 3 and K is going to be -2. The radius, I would just get it from right here. This distance is the easiest way to count. I mean, you could go up, but going from 3 to 0 is easier than going from -2 to 1. So I would, either way, it's going to be 3, right? So now we just need to clean this up. When we subtract the negative, it's addition, and 3 squared is 9. And this would be C, it looks like. Okay, so how do we do on that one? Ooh, well, that's surprising. Quite a few people drop off. B or D were the main questions that we were the main distractors we were choosing. B, we forgot to square the radius. Okay, so if you picked B, you found the radius was 3, but then you forgot to square it. And then if you said D, you got your 3, but you didn't do -3. You got your -2, but you didn't do -2. So your signs were wrong here and here. Remember number 1? 100% of you guys got that right. So this is one of those instances when I talked about how a couple people got it right on number 1, but then on the exact same concept on number 5 we missed it. So we got to be consistent with that information. Okay. Moving on, number 6. Now we're getting into arc length. So arc length is a fraction of the circumference. We know circumference is 2 pi r, and then we just multiply by the fraction out of 360 degrees, keeping it simple here. CD is looks like 80 degrees on this problem, so let's go ahead and throw an 80 in here. The radius is 9, so let's go ahead and throw a 9 in for the radius. And they did tell me to use 3.14. So we'll go ahead and throw 3.14 in as an approximation for pi. If you simplify things, sometimes things work out kind of nicely. For example, we know these zeros cancel, but 8 over 36 cancels all the way down to 2 over 9. And then, you could just get rid of these 9s. And so we just get, what, 2 times 2 times pi, 4 times pi. So that's 12.56, I believe, right? And is that one of the choices, hopefully, when we drop down the menu? Yes, it is, 12.56. So that was number 6. Not bad. I mean, it was better than the last one, and I thought that one might have been a little more challenging problem. A couple people did choose 6.28. So what I'm guessing on that is you forgot to do 2 pi r. You just did pi r, because that's exactly half of what the right answer should have been. Good job, though. Yes, thank you, Kylo. Number 7, another arc length problem. Just for variation here, I'm going to go ahead and set this one up as a proportion. So the length of the arc is to the full circumference, as the measure of the arc is to the full 360 degrees of the circle. And I used pi d on this one just because they gave me the diameter. I could have used 2 pi r and cut 60 in half and said the radius is 30, but I would have multiplied it right back. So what does it really matter, right? So the arc length they gave me here is 18 pi. So let's go ahead and plug that in. and the diameter was 60, and those pi's are certainly going to cancel. And 18 over 66 goes into both of those, as it turns out, 3 times and 10 times, okay? So now let's just cross multiply. 10x equals 1080, I believe, okay? 3 times 360, divide by 10, and we get a nice even answer of 108. Now the problem on this is a lot of people said that's my answer, 108. But remember, 108 is, you just found the measure of this arc. Remember what they asked for. They asked for this angle in here, right? And this angle is not a central angle, so it's not a one-to-one relationship. This angle is an inscribed angle, which is always what? Well, theorem 10.7 says half of the intercepted arc. So that would be 54. And boy, this was a problem for people, because as you can see, um, almost as many people kept the 108 as got the right answer of 54. Now, most people did still get 54, but 9 out of 23 is only 39%. 16 out of 23 would have been more respectable. That would have been, you know, a little over 70, well, right around 70%-ish, I guess. But boy, you got to remember that inscribed angles are not equal to the arcs, and that's just, I think, more paying attention to the problem than anything. But that is a slightly of a frightening display there. Um, I I would really have to look through at all of these different answers here to figure out what happened, because there were a lot of one-offs. Um, and if you kept your work, maybe you look back at it and compare it to the work we just did. All right, almost done. Number 8, find the radius of this given circle. So another arc length problem. Once again, they give us the arc length was 30 pi, right? So we're going to go ahead and plug that in for the arc length. I went back to the fraction times circumference formula, but you could have done the proportion formula again. It's really a matter of personal preference. Now here's another one where, maybe you fell victim to this two problems in a row. This is an inscribed angle, 30. So ML is not 30 degrees. It's definitely 60 degrees. And 60 over 360, well, the zeros cancel. We go all the way down to what, 1/6. But 1/6 times 2 is 2/6 or 1/3. So this reduces really nicely. By the way, I got rid of those pi's too. And then I just have to multiply each side by 3. Multiply each side by 3 to get rid of that 1/3, and 90 is your answer. If you forgot to double that inscribed angle, and you had a 30 here instead, this would have stayed at 1/6. You would have gotten a 180 answer for 90. So I wonder how many people did that, because this was the other of the most missed problems. And the answer is, wow, more people forgot to cut the angle in half than didn't. So it looks like we really need to go back and study those inscribed angles. I mean, you guys have a summative quiz next week. So we're reviewing this week, but you have a big summative quiz next week. And you can imagine there's going to be a ton of inscribed angle relationships on there. But 50% more people picked the wrong answer, 12, than the right answer, 8, or actually 180 versus 90. Yeah, it's an easy adjustment, but if you don't start paying a little bit closer attention to the correct angles, um, you're going to continue to miss these problems when really you're doing most of the work correctly. Number 9, I think we got back on track. It asked for the true statements here, and then it just gave you 3 circumferences and 3 areas. So really, it was just a matter of taking your radius of 18 and plugging it into the circumference formula, right, and the area formula. Once again, know your circumference formula, know your area formula, really important. 36 pi and 324 pi were the answers. If you forgot your pi here, you might have picked option 3. If you forgot 2 pi r, just pi r, you might have got option 1 or option whatever. boy, this one, if you got the circumference of 36 pi and you didn't see option 2, you might have said 36 pi inches squared for option 5, but that's an area and it even is listed as an area. So there's some mistakes that could have been made, but most of you guys did not make those mistakes. In fact, only one person didn't get the right area and only 2 people didn't get the right circumference. And together, 21 out of 23 got them both. All right, finally, number 10. This is another completing the square problem. So remember, we need to group our x terms together so that we can complete the x square. We need to group our y terms together so we can complete the y. Don't forget that minus with 10 that goes with it. This negative 15 needs to be added to the other side, so it turns out it's a 15 on the other side. Half of 6 is 3 squared is 9. Half of 10 is 5 squared is 25. Add those to the other side. Don't forget, that's a really common mistake, even like in pre-calculus when we do a lot of these completing the square problems for conic sections, including circles. A lot of people forget that. So anyway, this is going to reduce into a nice x plus 3 squared, and this is going to do a nice y minus 5 squared. And when you add all these together, you actually get 49. So what would be true? Well, it looks like your center would be the point negative 3 and 5. And it looks like the radius would be not 49, but the square root of 49. So based on what we saw there, option 4 would be true for the center, and option 6 would be true for, oops, 4 has negative 5, so 3 is the one with the positive 5. And option 6 would be true for the radius, so 3 and 6. And not bad, 74%. I mean, here's something that is interesting. On the only other completing the square problem, which was problem 2, which was really the same exact process, right? Exact same process, just a slightly different number. 91% of you guys got the right equation, because that's all you had to do on this one was get the right equation. 91%. Now on number 10, which is pretty much the same problem, but we had to interpret the equation once we got it, it dropped about 20%. Surprising a little bit. It's not terrible. It's not like number 7 and number 8 where more than 50% of you were missing them, but it was a little bit surprising. The bonus problem was one that very few people got, but it was one that was very similar to some problems you'd seen on your recent reviews. It started you off with 2 points on a circle, negative 28, negative 15, and 8, negative 29. All you can really do with those 2 points is understand that since they're on the circle, they will create a chord. Okay? And they tell you, because they want you to find the center, something about the center. They tell you that the y value of the center is going to be 1, right? And this is important because you see, we know from theorem 10.4 that the perpendicular bisector of any chord will always go through the center of the circle, always. And so if I created the perpendicular bisector of this chord, if I found midpoint and drew the perpendicular bisector, it would go through that center point. The problem is that any point on this line, and there are infinitely many points on that line, could be the center. So, if I picked the center to be the midpoint itself, then it would be a diameter and that would be a circle. But what if I made the circle just a little bit bigger so that it wasn't quite the diameter, but it was still towards the center? Well, now your center point is going to be, this is just an approximation, but probably around here, right? But what if I move that point over a little bit? Well, that's going to slide the circle even further out with that chord. Now we have something that looks more like this. So by all we know about the center of the circle is it's on that line. There's infinitely many points. I mean, I could have a huge circle that just barely hits these 2 points that are pretty close to each other on the circle for a chord like that. Now the center is way up, somewhere here. So this problem, either was going to give you another chord where you had to find the perpendicular bisector, or it was going to give you, a hint. And this one decided to be nice and give you a hint, and they gave you um, part of the point. So we'll take that hint, right? We'll take it and use it. So let's find what we can find, because there are only two things I know we can find for sure. Anytime you have 2 points, right, which creates a line segment, anytime you have 2 points, you know that you can find its midpoint, which we're going to need because I don't have any points on this line right now. So I'm going to go ahead and add those 2 points together and divide by 2. So x plus x over 2, y plus y over 2. So now I know that this point right here is -5, -22. Okay, so we needed that. That was pretty important. But I could also find the slope of this chord. It looks like it's negative. This is just a rough sketch, but it definitely looks like it's going down. But if I do y minus y over x minus x, I get a -7/23. So that's kind of a nasty number, but it is going down. Now, that means that the opposite reciprocal, this guy going up, would be +23/7. That's your perpendicular slope. So I have 2 pieces now. And if I have a slope and a point on a line, if I have a slope and a point of a line, I can always find the equation of the line. I would just plug in the slope and the point, or m, x, and y, and I would multiply, and I would add, add in this case, and solve for b. Now, you can pause this if you need to look through this, because I know fractions are a little bit harder to follow, but this is what you come up with, okay? Notice how I got some common denominators there. So now that I have my equation of my line, which would be y equals 23/7 x minus 39/7, I can take that hint they gave me, that value of y, and I can plug it in for y, leaving me only with this x value to solve for. Now, it doesn't mean it's easy because of the fractions. I would have to add the 39/7 to the other side, and then probably multiply by the reciprocal here, right? The reciprocal of 23/7, 7/23. And so the nice thing here is these 7s cancel, and you just get 46 over 23. And that turns out to be exactly 2. So that's kind of nice. And that's your answer, 2. Now, some people may say, well, isn't there an easier way? And I guess you could have used point slope form. Less people are familiar with this form, but if you use point slope form, so you plug in your point and your slope, so it's all the same values, just in a different arrangement, you can just multiply the whole thing through by 7 and get rid of all those fractions right away. Maybe makes it a little bit easier. I guess we could have done it on this other one, where I could have just multiplied everything through by 7, and it probably would have been even easier with slope intercept, but that is another way that you could have done that. Just fractions are less easy to work with. But that's your bonus. The x value was 2. And speaking of 2, that's how many people got it right. So 2 out of 23 was 8%. Now, only 11 people tried this bonus, so really that was 18%. But still, a lot of people struggled with the bonus, somewhat to the point where they just said, I don't know, which is certainly not the answer. Anyway, hey, there'll be another challenge, and your next challenge is actually going to be a summative quiz next week. It'll probably be about twice as long as any of these quizzes you've taken, and it's going to cover all of those theorems and definitions at the same time. So far, you've only been responsible for around 5 or 6 theorems, formulas at a time. So next week, it's going to be all together. And we're going to have a lot of review this week. And speaking of which, I'm going to go and run a review session for you right now. So let me know if you have any questions on this quiz. But good luck with your reviewing, and make sure you get yourselves ready for next week. Adios.